Hey guys, the goal of this video is going to be to show the relationship between momentum and impulse. Okay? Now on the board here I have written the momentum equation. Momentum is this lowercase p, which is equal to mass times velocity, okay? Which gives us the units of a kilogram meter per second. Okay, nothing fancy, but that is going to be the units for momentum. Now momentum can also be seen if we take this equation, which is F equals ma, which is a very common physics 1 equation, and we expand a to equal its definition, which is the change in velocity over the change in time. If I multiply both sides by delta t, I get F delta t is equal to m delta v. So force acting over a certain period of time is equal to a change in momentum. Okay? This is what the impulse momentum theorem is about. Now, if you've ever played any sports, you'll recall that your coach probably always told you to follow through. Okay? What does that mean? Well, in soccer, you follow through with your kick. In baseball, you follow through with your swing. In tennis as well. In swimming, you follow through with your stroke. Okay? What does a follow through do? Well, in sports, oftentimes the objective is to hit the ball as hard as you can. Because the harder you hit it, it's less likely for the opponent to be able to maybe hit it back or catch it. So, what we're trying to do is we're trying to get the ball to experience the largest change in momentum. Well, how are we going to do this? Well, we want force to be applied on the object or on the ball for the longest amount of time. Okay? And that's accomplished by a good follow-through. So if my other hand can be imagined as the ball comes into contact with the bat, you want to follow through so that both are in contact for as much time before the ball releases and continues to travel on. Okay? And so this is the impulse momentum theorem. Now on the flip side, we can also use this theorem to explain why airbags are so useful. Okay? So now let's imagine two cases where you are in a car traveling at 40 meters per second and you're in a car that is equipped with an airbag and one that's not equipped with an airbag. Okay? So in both cases, if you were to get into a head-on collision, your change in momentum would be from the 40 meters per second to 0, to rest. Okay? And the amount of time it takes for maybe your head to stop when you are using an airbag is going to be much longer than the time it would take for your head to stop if you were not using an airbag. Okay? So again, the change in momentum part is going to be the same, but what we want to do with an airbag is we want to increase the amount of time that it takes for us to stop, and therefore if time is increased, then the force has to decrease. And so the airbag creates a nice cushion, or it makes a longer time for us to stop, and therefore the amount of newtons, the force that is going to act on our head, is going to be less. And therefore maybe preserving your skull and your brain. Okay? So in sports we want to increase the impulse, therefore we want to increase the momentum, but on the flip side, when we're thinking about maybe a car accident and airbags, we want to try to increase the time of the collision so that the force is going to be lower. Okay? Hope this makes sense. And stay tuned for some example problems dealing with momentum and impulse, and also with collisions. See you soon.